Okay, so now we're doing part C. So part C wants us to find the PDF of x times y, which is equal to z. So we remember that first we need to find capital F of x, f of z, and then from there we can find little f of z, which is the PDF. So big F of z is equal to the integral of z random variable less than or equal to z. Well, what's z random variable? It's x random variable times y random variable less than or equal to z. So over this area we have to integrate our little f of xy. So we can rewrite this condition as y random variable is less than or equal to z over x random variable. So that will look like this. This curve over here, this curve will be y less than or equal to z over x, y random variable less than or equal to z over x random variable. But we remember that x random variable and y random variable must both be greater than or equal to 0. So we're only considering the area that's shaded here, this area over here. That's the only area that we care about. So we want to come here. So big F of z, I'm going to integrate with respect to y first. So the limits are y goes from 0 to z over x. So that's the first two limits. And then dx goes from 0 to infinity. So I have here the little f of xy, e to the minus x times e to the minus y. That's equal to this. So I do the integration with respect to y. So that's going to be, we'll bring down the minus, and it's going to be minus e to the minus z over x minus, but we still have another minus, so it becomes a plus, e to the minus 0, so it becomes 1. This is what we're left with. So now what I'm going to do, I'm going to distribute this e to the minus x over. So what's going to happen, I'm going to have minus e to the minus x minus z over x dx, and I separate it into the other integral for the sum. So it's going to be an integral from 0 to infinity of e to the minus x. Now this integral is complicated, so we're just going to leave it in that form. And this integral here is just going to go to 1, because we're going to have a minus e to the minus infinity, which becomes 0, minus plus e to the 0 becomes 1. So we're just left with 1. Now to find little f of z, we need to take the derivative of this thing with respect to z. So that's going to be over here. So we want to take the derivative of big F of z with respect to z. Now, because the derivative with respect to z has nothing to do with the variable that's being integrated here, we can interchange the order of the integral and the derivative. The derivative of 1 with respect to z is 0. So what we're left with is the integral from 0 to infinity of what is the derivative of this guy with respect to z? Well, it's just going to be minus 1 over x. So we bring down the minus 1 over x, the minuses cancel, and we are left with 1 over x e to the minus x minus z over x dx. Now, before I circle this answer, I want to remind everyone that x is greater than or equal to 0 and y is greater than or equal to 0. Therefore, z random variable must also be greater than or equal to 0. So this holds for z greater than or equal to 0. So we could also write little f of z as the integral from 0 to infinity of 1 over x e to the minus x minus z over x dx times u of z, because it's only valid for z greater than or equal to 0. Z greater than or equal to 0. And that completes part C.